Isotope notation. Isotope notation is a way that we can write the symbol for an atom and show the number of protons, neutrons, and sometimes electrons that are in it. Isotope notation, you see it all over chemistry, but it's particularly important in nuclear chemistry. Because in nuclear chemistry, it's all about the nucleus. And so when we write down an atom, we want to be able to show pretty quickly how many protons and neutrons are in it. So, here is what it looks like to write an atom in isotope notation. We got a couple things going on here. First, we got these letters. The letters represent the element of the atom that we're dealing with. So here it's Mg, so we know, which stands for magnesium, so we know we're talking about an atom of magnesium. Then we got these numbers here. The number down here is the atomic number. It's the number of protons that are in the nucleus of this atom. So here we have 12 protons in the nucleus, an atomic number of 12. The number up here is called the mass number, which is the number of protons plus the number of neutrons. Don't make the mistake and think that this is the number of neutrons, because it's not. It's protons plus neutrons together. Then we've got 2 plus here, and this represents the net charge of this atom. So we've got protons and electrons, and they balance each other out. So we have the same number of protons and electrons have a net charge of 0. But unless we have the exact same number of protons and electrons, the atom is going to have a charge that's a little bit negative or a little bit positive, and that's what the net charge represents. When we write something in isotope notation, it's usually because we want to be able to find out the number of protons, neutrons, and as I said, sometimes electrons if you're adding the net charge in here. Let's do this now. How many protons are in this atom? Okay, that's easy. The atomic number here is 12, so 12 protons. How many neutrons in this atom? Okay, that's a little bit harder because we don't have a number here that's actually neutrons. But this number here is protons plus neutrons together. So if I know protons and neutrons, and I know the number of just protons, I can take my protons and neutrons, my mass number, and subtract the atomic number. Subtract the number of protons, and I get 25 minus 12. It's going to give me 13 neutrons, the mass number minus the atomic number. Okay, finally electrons. Here's how I like to think about it. This is a net charge of positive, so it means that we have to have more protons than electrons. And since it's 2 plus, it means we have to have 2 more protons than electrons, okay? So if we had 12 electrons, these guys would balance out and they'd be neutral. Since I need to have 2 more protons than electrons, I want to take the balanced number of electrons minus 2 is going to give me 10 electrons. Now I have 2 more protons than electrons, and that's going to give me a plus 2 net charge. Let's do another example here. Let's swap in titanium. Now you'll see something right away about titanium, and that's that titanium doesn't have a net charge written here. And so if you write an atom, you see an atom written in isotope notation, and it doesn't have a net charge, that means, if it doesn't have a net charge written up here, that means the net charge is 0. The protons and electrons balance perfectly. So, protons, neutrons, and electrons for this guy. Protons is the atomic number, 22. And neutrons, the mass number, 48. Protons plus neutrons, minus 22, the number of protons. And we get 26 neutrons. For electrons, they balance out with protons, and as we said, since there's nothing up there, it has a 0 net charge. So that means I've got 22 protons, and I've got 22 electrons. Okay, so now I want to go in the other direction. Instead of taking a symbol and finding out the number of protons, neutrons, and electrons, I want to start with protons, neutrons, and electrons. I already know how many I have, and I want to write this symbol here. Okay, so let's start out with the atomic number, 15 number of protons, okay? I'll write that in right here. Now how about the mass number? Well, the mass number is protons plus neutrons, so I'll take 15, add it with 17, and I'm going to get 32. So that's the number that goes up here, 32 for the mass number. Okay, what's the letter that goes here? What's a chemical symbol? Well, in order to find that out, I have to look on the periodic table. And I want to look for the element that has an atomic number of 15. If I do that, I find out here that it's phosphorus, because I've got this 15 up here. So that means that any atom that has 15 protons in it has an atomic number of 15, it's phosphorus, okay? So I put a big P here that stands for phosphorus. And now the net charge. What's going on here? I've got my electrons and I got my protons. In this example, I have more electrons than I have protons, which means that my net charge is going to be negative. I've got 3 more electrons and protons, so that means that the net charge is going to be 3 minus. I kind of like to just figure it out, think about how many more electrons or protons I have. But if you want to know how to always calculate the net charge, you can take the number of protons and subtract the number of electrons from it, and there I get -3, and that's my net charge. We usually write things 3 minus when we're doing the net charge, 2 minus, that kind of thing. Let's do another one of these. Okay, so what's the symbol of this going to be? It's always best to start with the atomic number because that's really straightforward. 18. 18 protons in the nucleus. Now how about the mass number? I'm going to do protons plus neutrons. 18 plus 22 is going to give me 40. So the 40 goes up here. How about the symbol? The symbol is dependent on this number here, 18. I look on the periodic table to find out the atom that has an atomic number of 18. And that's argon, right here. So Ar is a symbol there. How about the net charge? How do the protons and electrons balance out? It turns out that I have 18 protons and 18 electrons. So they balance out perfectly, meaning that my net charge is 0. I just leave it blank. I don't write anything in there, and that tells me that I don't have a net charge there. Okay? So that's how we can take an atom written in isotope notation and figure out the number of protons, neutrons, and electrons that it has in it. And then we can also do the opposite. We can take a given number of protons, neutrons, and electrons and go ahead and write the symbol for it. So that's isotope notation.